In day 10, we start reviewing the families of functions that we've looked at over the past few days and their characteristics. Warm up, is line f a function? How do you know it is or isn't? So if you take a look at our function right here, line f, we can use the vertical line test to tell if it's a function or not. What the vertical line test does is each vertical line would stand for the input, and then where it meets your graph, that would be the output. And what you're looking for is for every input, is there only one output? And you can see that if a graph is linear like this, that yes, this will be a function because for every red line, you only have one place where your vertical line meets the graph. So yes, we would say it's a function. How do we know? Well, we can tell by using the vertical line test. Again, that says if you drop a vertical line anywhere in your graph, it will only meet your graph in one place. So let's review the different parent functions that we've looked at this unit. So we started with linear. We know a lot about linear from Algebra 1 and geometry. Then we looked at quadratic functions. So if it's a quadratic, the highest power is an x squared. You'll see an x squared in it. And so it'll look like this. Y equals x squared is the parent function. And if it's shifted, you'll have your h and your k. So I should have probably put a spot for the shifted function. So what I'm going to do is I'm going to put the parent function on the top. So y equals x squared. The shifted function, if it goes left or right, the only thing in the parentheses is the x and the left or right shift. Remember, the h value is the opposite of what you think. So if it's minus a number, it's to the right. And if it's plus a number, it's to the left. You'll see that squared on the outside of the parentheses. And sometimes you might see a number added or subtracted to your quadratic, and that would move the graph up or down. So there's the shifted equation right there where h and k are your horizontal and vertical shift. All right, so the graph of the parent function, the vertex is at 0, 0. If we make a table to fill out the values, we just square the numbers. Whoops, it's not going to like when I do that. So like -2, -1, 0, 1, 2. If I square each of those numbers, I'll get the output. And so again, that's the rule. If you square the input, you'll get the output. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So if I sketch the graph of that, it will look something like this. And again, this is a quadratic function. We describe the graph of a quadratic as a parabola, a U-shaped graph. So again, when you have a quadratic, it's a parabola, a U-shaped graph. The vertex is where it changes direction. So our graph on the left-hand side goes down as we go to the right, and then it pops back up. So the vertex is at 0, 0, where the graph changes direction. The domain and range, domain is all possible x values, and here the x values are all real numbers because your graph keeps going to the left and it keeps going to the right as we look at that. So we say our domain is all real numbers, which is the double line and the R. That means all the numbers on the number line. It goes all the way left, all the way right, meeting all the negative numbers on the number line, the positive numbers, 0, fractions, and so on. The range is low to high, and it's the y values. And if you notice, there is a lowest value right here. It's 0, and then everything above 0. Those are your y values of the graph. So we say y is greater than or equal to 0 for the range. Okay, so there is one of the families of functions that we looked at, the quadratic. Another function that we looked at is the absolute value function. And again, I'll write the parent function at the top. So here's y equals the absolute value of x. So remember, absolute value is distance from 0. The shifted equation looks a lot like your quadratic. You have y equals, inside the absolute value, that's like your parentheses. So we have your x minus your h value. H is left and right, opposite of what you think. And then the plus k is on the outside, and that's up or down, and that's what you think. So again, you have to know how that shifts your absolute value function. I'm going to graph the parent function, also called the mother function. And again, to graph that, you can just make a table, which we did in the earlier part of the unit. So you can always go back and look at what we've done before by going to Google Classroom and looking at the videos that I've linked to before. So for this one right here, again, I'm just going to make a table, -2, -1, 0, 1, 2. And now we're looking at absolute value. And so the absolute value of -2 is 2 because that's the distance from 0. The absolute value of -1 is 1. We have 0, 1, and 2. And then if we graph that, here's what it looks like. So pretty much when you look at absolute value, it's a V-shaped graph. The vertex is still 0, 0, like in your quadratic. The domain is still all real numbers because your graph still goes all the way left and all the way right. And like a quadratic, the range is greater than or equal to 0 because you don't have any graph below where y equals 0 right there. Other things that I should point out is in my equation right here with the h and k, I forgot about the a value. So we did talk about the a value, which is like the slope. And so in our parent function, the a value, the number in front is invisible, so it's an invisible 1 there. And what that means is when you graph it, you find the vertex, and then from that vertex, you go up 1 over 1 in each direction if the a value is 1, and you do that both ways. And that's an easy way to get the rest of your graph. So if the a value is different, it's kind of like the slope of each line. Again, we did talk about that when we looked at absolute value. And then the last function was a square root function. And so again, the parent function, or the mother function it's called, is the square root of x. And again, you can shift it. So we have the square root of, under the square root sign, that's like your parentheses. So under the parentheses is your h value. The k value is on the outside. Oh, I kept that blue. I should keep it blue and be consistent. So again, the k value is outside the square root sign. And then to graph the parent function, again, we can't take the square root of a negative number. So when I make my table, I'm going to start at 0. I'll go to 1, I'll go to 4, 9, because I can take the square root of those numbers. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So when we graph that, here's what it looks like. 0, 0, 1, 1, 4, 2, and it slowly increases. So there is our square root function. Here the starting point is at 0, 0. The domain here is not all real numbers because if you notice, there is a leftmost spot for our graph right here. So here our graph starts at 0 and it keeps going. So we say that our domain, x, is greater than or equal to 0 because that vertex is a closed dot. And for the range, again, there is a lowest value, y equals 0. And again, it does keep increasing. So for a range, it's the same as the other two. Y is greater than or equal to 0. So you should make yourself familiar with these different traits of the functions. And then you can practice that as we take a look at, it says day 11 daily practice, but it should be day 10. All right, so let's review. So now that we've looked at these parent functions, the vertex of each, the domain and range, let's talk about these shifts more in depth. So again, we did talk about the shifts here a little bit, but let's finish talking about the shifts or the translations of the graph. I will ask you, how do these graphs shift up, down, left, and right? I'll also ask you about the dilation. Does it get bigger or smaller? And you can tell by looking at the slope. So let's talk about where you find all that in each of these equations. I just picked the absolute value equation, but just know this can be the same as the square root equation. It can be the same as your quadratic. Oh, so I guess I did do an absolute value and square root. I should have probably picked one or the other. I'll just make it a quadratic. Okay. All right, but again, if it was an absolute value or a square root, it would behave in the same way. All right. Actually, no, I'll look at absolute value. Okay, so absolute value, let's ignore the squared if it's absolute value. Okay, so the a value right here, that is your slope, like your slope. And in an absolute value, whatever that number is, you would start at the vertex and you would go up and over or down and over the rise over the run for that a value. The next thing that we're going to look at is inside the parentheses or the absolute value sign or the square root sign. The negative h value means it goes to the right h units. The positive h means it goes to the left h units. And outside the absolute value, square root, or parentheses, the k value is up or down. Plus k is up, minus k is down. All right, so what will that look like? What will I ask you? I might ask you like something like this. Write an equation of a graph that has shifted 4 units up and 5 units to the right. So we can see the 4 units up is that plus 4. The 5 units to the right is the minus 5 inside the parentheses. I might go the other way and give you an equation and say, what's the shift of the graph? So here, how does this graph that I underline in blue shift? Well, the plus 2 on the inside of the parentheses is left 2, and the minus 3 on the outside of the parentheses is down 3. So again, this will be in your practice that you have today. And of course, I'll put the answer key up so you can check your answers. Last thing I want to review is reflections. So let's say we had some parent function. I made this funny looking graph here, f of x. So there's our parent function. Let's do the following reflections. So if the negative's on the outside, this reflects over the x-axis. So what that looks like is here's the x-axis, so the reflection, I'm just going to go the same distance away, like the mirror line. I'm just going to make my dots. This is 3 away, and this is 2 away. So I'm just counting the distance between them and drawing it. So again, it's the same distance from this mirror line, and there we can see negative f of x. Now, how to remember which way to reflect it? Well, if the negative comes first, I always think x comes before y, so if the negative comes first, I flip it over the x, because x comes first. So there's your reflection over the x-axis. A negative on the inside would be a reflection over the y. Reflection over the y-axis. And so what that looks like, again, I'm going to start with my parent function, my original function. And here's the y-axis, and again, I'm thinking mirror image. So this dot reflects over here. This one's 3 away from the mirror line. This one is 4 away from the mirror line. Okay, so there's my reflected function. Just think same distance from the mirror line. Again, how did I know to reflect this one over the y-axis? The negatives on the inside come second, and so I think y comes after x, and so reflection across the y. So this is f of negative x. And then if you have two negatives, so a negative on the outside of the function and on the inside of the parentheses, that's a reflection over the x and the y. So it's going to be diagonal from, or kitty corner, from the original function. So this is a reflection over the x and y axes. So if I reflect it over the x and then over the y, it's going to end up here. This one over the this, and then 3 up. And you could do either one first. I can go over the x and the y and the x. Looks like I'm doing the y and the x first. So this is 4, and then it's 2 up. Okay. All right, so there's our final reflection, negative f of negative x. Again, it's diagonal from the original function. So that is a very brief review of the unit. We've looked at several different functions and how they behave. And so to practice, again, it was the day 11 daily practice, but it should be day 10. So start here on this page, which appears to be page 50, so the middle of page 50. Again, you're going to graph each of these functions again, and then it'll ask you questions about the behavior of the graph. So it goes from 50, 51 to 52. So pretty much you're finishing up the packet. And of course, check your answer. And we will do more review in the following days.